vessel and answer our problem 7.99 in lesson 14. But before that, we're gonna tackle first about the importance of studying engineering mechanics of deformable bodies. So the purpose of studying mechanics of deformable bodies or strength of materials is to make sure that the design of a structure is safe against the combined effects of applied forces and moments. So now let's tackle about the thin wall pressure vessel. So the thin wall pressure vessel has a similar analysis with Hooke's law, to where there are given stresses acting on the edge of the vessel, to which you can use the Hooke's law. So in a pressure vessel, there is a thin wall and there is a fluid entering with a certain pressure will flow. So the wall will be subjected to the forces acted by the fluids. In order to us to calculate thin wall pressure vessel problems is to first determine the types of stresses present in a pressure vessel. The hoop stress is there is a force, or the force exerts is perpendicular to the area of the wall. So it creates stress on the wall and it will make the wall deform. So as you can see in figure 5, the hoop stress, it has a summation of forces at axis Z using equilibrium forces that equates it to 0. So equates the equation to 0, and the hoop stress is now equal to PR over T. So the longitudinal stress are forces acting parallel to the thin wall of the pressure vessel. So it has a summation forces of axis X using the equilibrium forces that equates it to 0. And the equation to 0, the longitudinal stress is now equal to PR over 2T, in which P is the pressure, R is the radius, and T is the thickness. So the forces acting on the thin wall are called the principal stresses. So now we are ready to solve our problem 7.99.
The problem. The maximum gauge pressure is known to be 10 MPa in a spherical steel pressure vessel having a 200 mm outer diameter and a 6 mm wall thickness. Knowing that the ultimate stress in the steel used is 400 MPa, determine the factor of safety with respect to tensile failure. We have a given of a maximum pressure in steel pressure vessel is equal to 10 MPa, the outer diameter of a pressure vessel, which is 200 mm, which is now converted to 0.2 meter, the wall thickness of the pressure vessel, which is 6 mm, which is now converted to 0.006 meter, and the ultimate stress of the steel, which is 400 MPa. And we're going to find the factor of safety. Solution. So the first thing we have to do is to find the radius of the pressure vessel. So the radius of the pressure vessel is 1/2 of the outer diameter of the pressure vessel minus the wall thickness of the pressure vessel. Given the formula, we are going to input the value of T sub O, which is 0.2, and the value of T, which is 0.006. And now we're going to calculate the equation, and now we have the radius of 0.094 meters. The next thing that we're going to do is to find the maximum normal stress. So the stress 1 is equal to the longitudinal stress, which is the PR over 2T. Now we're going to substitute the following value of the pressure, 10 MPa, the radius 0.094, and the thickness 0.006. Calculate the equation, then we'll be going to get our working stress of 78.33 MPa. Now that we have the working stress, we can now calculate the factor of safety. So the formula of the factor of safety is equal to ultimate stress over the working stress. We have a ultimate stress of 400 MPa over the working stress 78.33 MPa. Now we're going to divide the following, and we're going to get the answer of 5.1066. which is now we have a factor of safety of 5.11. And now we're done. Thank you for listening, and see you all to the next problem.